All right, the next thing that we're going to do is divide complex numbers. So um, the process to divide is actually called rationalizing the denominator. So for these problems, we're going to be rationalizing the denominator, and we have a rule that says you're not allowed to ever have a radical or an imaginary number in the denominator. So what we do is we multiply top and bottom by I. Okay, so for this, when we distributed before I, and then I times negative I is a minus I squared. And on the bottom, we'd have 6I times I, which is 6I squared. So now, what does this give us? Again, going back to what we talked about earlier, I squared is equal to -1. So I would replace this with a -1. So it would be 4I minus, this is this minus sign, a -1, all over 6 times -1. Where the negative ones come from I squared. So that would equal 4I plus 1 all over a -6. And again, we would never write it this way. We would always put the real number first, so it would be 1 plus 4I over a -6. And then we would break this up. So you would see the answer is -1 over 6 minus, I could simplify this 4 and 6 to a 2 over 3I. So really, anytime you have an imaginary number in the bottom, you just simply um, multiply by I. Now, when we have two terms in the bottom, this is a little bit different. We have to do what's called multiply by the conjugate. Okay, so we're going to multiply by the denominator's conjugate. Okay, the conjugate is all we do is change the middle sign. So change the middle sign in the denominator. Okay, so that's all the conjugate is. So I'm going to rewrite this as 5 minus 2i over 3 plus 4i. I'm going to multiply top and bottom, okay, by the conjugate. The conjugate of the denominator is 3 minus 4i. 3 minus 4i. Now, it becomes a lot of work, okay? It becomes a lot of work when I do this, but I have to FOIL this out like I did, okay, which is 15. That'd be 5 times 3. Then 5 times -4i is minus 20i. -2i times 3 is -6i. And then -2i minus 4i is a positive 8i squared. All over on the bottom. And this is why we do this. Watch what happens. I'm going to do the whole thing out. 3 times 3 is 9. I get a minus 12i, a plus 12i, and a 4i times -4i is a minus 16i squared. So now I combine like terms and simplify. Look at what happens on the bottom. On the top, I do what I did with multiplying. Okay, I'm just going to go ahead and combine like terms. I've got a 15. Remember what happens when I have an I squared? This is going to turn to a -8. So I'm going to kind of do two things at once. 15 and then a -8. Where'd the -8 come from? I replaced this I squared with a -1. So 15 minus 8 is 7. -20i minus 6i is minus 26i. All over. Look what happens here. My i's, my middle terms cancel, and what happens to this I squared? It turns to a -1. So this is really a plus 16. 9 plus 16 is 25. So this simplifies to 7 over 25 minus 26i all over 25. Now, I do want to show you that our calculator is a very, very, very useful tool when it comes to imaginary numbers and multiplying and adding and subtracting. So there's going to be an opportunity that if you have this graphing calculator, and if you don't, Desmos doesn't work, but there's another couple websites. Papa Math is another one that allows you to put in the imaginary unit. But if I have this problem, let me minimize this so you can see my calculator. Okay, and I literally just put in 5 minus 2i. So 5, I always put the complex number in parentheses, 5 minus 2, and then the little I is right here. You have to hit second, and then you have to go to the alphabet, which is I right here. Okay, or it's also down here where the decimal is. So second I, divided by, again, make sure you're using parentheses, 3 plus 4, and then hit second and go down to the decimal point. Make sure you close the parentheses, you hit equals, and it will always give you your answer in decimal. All I have to do is hit math, fraction, and it will change to 7 over 25 minus 26 over 25i, which is exactly what we got. So you can multiply, divide, add, subtract using your calculator on all of these problems. Okay, but this is called multiplying by the conjugate. And again, the reason we have to do this is the math rule says we're not allowed to have an imaginary number in the denominator. So if you ever have an answer where you have an imaginary number in the denominator, it's going to be wrong. Then there's going to be one other type of problem that kind of stems off of what we did in 4.6 with radicals. Okay, I'm going to start off with a very simple one where if I had an x plus 3 squared is equal to, let's just say, negative 24. And I asked you to solve this. We'll recall back to 4.6. I'm trying to get this x by itself. I don't want to have to multiply everything out and do all of that extra work. I just want to get rid of this squared. So I'm going to square root both sides. Okay. Square root both sides, and that would give me x plus 3. Again, the square root and the square cancel. Well, over here on the right, before, I wouldn't be able to do this. You can't punch this in the calculator. It tells you no solution. Now I can actually simplify this. How does this simplify? Going back to the last video, remember we can rewrite this as the square root of negative 1. And then I want to look for a perfect square factor, which is square root of 4 and square root of 6. So this is really the same exact thing as writing 2i square root 6. And again, because I took the square root of both sides, the answer is going to become plus or minus. So where'd the 2 come from? That came from this 4. Where'd the I come from? That's the negative 1 underneath the radical. And then square root of 6 doesn't have a perfect square factor, so I can't simplify that. And then now, solving for x, I just put a minus 3. So it'd be x equals negative 3 plus or minus 2i square root 6. And this would give me my two answers. The two answers would be negative 3 plus 2i square root of 6 and negative 3 minus 2i square root of 6. Again, these are written as complex numbers, where I have the real number first and the imaginary number second. Okay, it doesn't matter the order you write this in, but again, just get comfortable because this is what it always shows in the book. Now, these problems can get a little bit more challenging. They can look like this. Okay, negative 3, 2x minus 5 squared plus 8 is equal to, let's just say, and I'm making this up, so 81. Well, how would you do this? You would subtract 8. That would give you a negative 3 parentheses 2x minus 5 squared equals 81 minus 8 is 73. And then I would divide by negative 3. So now I'd have a 2x minus 5 squared equals negative 73 over 3. And then here I would square root both sides and go through solving that. Okay. The key is getting whatever's being squared by itself, take the square root, and then understand that over here you are going to have a negative underneath the radical that you're going to have to simplify. And then you just solve for x. So there's a couple problems like that you're going to have to try to work through. Again, if you have any questions, please ask me. These problems are starting to get a little bit more challenging as we're moving forward here. The calculator will help you quite a bit if you have one. If not, I'll show you Papa Math here at the beginning of class.